This is you, watching this video from your phone during your lunch break. Look at you, pinnacle of evolution. But how did we get here? We can rewind the clock 13.8 billion years to the dramatic birth of the universe, or 4.5 billion years to the formation of our planet. However, for the sake of this story, let's venture back a mere 210 million years. Environmental changes are happening. Not the first time, won't be the last time. Breakup of the supercontinent Pangaea set up the stage for opening of new habitats, creating opportunities for organisms with novel adaptations to exploit new ecological niches. Among the emerging dinosaurs in this era, Morganucodontids were one of the earliest known mammals to roam the Earth, and all mammals currently walking the Earth are descendants of the surviving line of Morganucodontids. These rodent-like creatures were 10 to 15 centimeters, 4 to 6 inches, in size. While we might think of ourselves, humans, as undoubtedly at the top of the food chain now, our predecessors had a tough time staying away from dinosaurs' paths in order to survive. As small insectivores, they would have preyed on insects and other small invertebrates, which would have been abundant in their habitats. They had relatively large brains compared to their reptilian relatives, and possessed several mammalian characteristics, such as differentiated teeth, a secondary palate, and specialized jaw joints. Fossil evidence suggests that Morganucodontids may have exhibited some degree of parental care, as indicated by the presence of relatively large brains and well-developed inner ear structures, which are associated with hearing in newborn mammals. For almost 150 million years, they survived, hiding from giants and witnessing their dominance. Early mammals kept adapting to their environments. These adaptations included nocturnality, burrowing behaviors, group living for protection, and reproductive strategies such as parental care to ensure the survival of offspring. Reminds you anything? But despite mounting pressure of survival in the most challenging period yet, Morganucodontids and the lines of mammals they gave rise to ensured that their DNA was passed on to eventually, incredibly far in the future, create something truly unprecedented. Us. Approximately 65 million years ago, a mass extinction event set off a new, unexpected turn in our history. A massive asteroid impact, which created the Yucatan Peninsula in Mexico, led to an unimaginable explosion, wildfires, volcano eruptions, and tsunamis. In this post-apocalyptic world, non-avian dinosaurs had no chance for survival, but we did, our predecessors did. Through explosions, fire, and flooding, our small size, diet, and most importantly, ability to adapt ensured our survival through new challenges. This time, perhaps, not only just to survive, while the mass extinction event had devastating effects on many species, including non-avian dinosaurs, some mammalian species survived the catastrophe. These survivors included small nocturnal mammals that were able to find shelter and food in underground burrows or other protected habitats. These small mammals formed the basis for the recovery and subsequent diversification of mammalian life. With the disappearance of dominant dinosaurian competitors, mammals experienced an adaptive radiation, wherein they diversified and occupied a wide range of ecological niches previously filled by dinosaurs. Mammals diversified into various forms, including herbivores, carnivores, omnivores, burrowers, climbers, and gliders, among others. This diversification led to the evolution of numerous mammalian lineages adapted to different lifestyles and environments. Following the extinction event, mammals underwent further evolutionary changes and speciation, leading to the emergence of modern mammalian groups. These include the evolution of placental mammals, which became the dominant group of mammals, as well as the diversification of marsupials and monotremes. Over millions of years, mammals continued to evolve and adapt to changing environmental conditions, giving rise to the diverse array of mammalian species present today. Fast forward to 7 million years ago, Sahelanthropus chadensis emerges on the savanna woodlands of what's now Chad, Africa. Sahelanthropus chadensis, considered one of the earliest known members of the human lineage, hominins. While the precise evolutionary relationships of Sahelanthropus to other hominins are still debated among paleoanthropologists, it is believed to represent a basal member of the hominin lineage, potentially close to the divergence between the human lineage and the lineage leading to chimpanzees. Sahelanthropus evolved from an earlier ape-like ancestor, possibly a common ancestor shared with chimpanzees, in the context of African ecosystems during the late Miocene epoch. Thank you for watching this far. I am humbled and overjoyed by the amazing support you've shown me. Every view, every like, every share, they all mean the world to me. This journey wouldn't have been possible without you, my amazing viewers. You won't want to miss what's coming up in part 2 of this video. Cheers.